All right, so this is section 3.6. We're going to talk about slope-intercept form. So this says we're going to use the y-intercept and the slope to graph this line. So first off, it says last year Gary spent $4,000 upgrading the LAN for his company's computer system. So that means the initial cost that he spent was $4,000. So I'm going to put that in this table of values. And the corresponding years since the start of the program would be 0, since this is initially what he started with. Now it says he plans to spend $3,000 every 2 years to update his employees' laptop computers. So in other words, $3,000 every 2 years, or we could divide 3,000 by 2 so we could see how much he's spending every 1 year. So that means for every 1 year that we add to this table, we're adding an additional $1,500 to the amount he is spending on the LAN. All right, so there are my coordinates. And the main thing I want you to get from this is you see I've labeled both of my axes and I've graphed my initial point, 0, 4,000. So we know from last week that 0, 4,000 is the y-intercept because the x value is 0 for the corresponding y value. And the y-intercept sometimes is called the starting point of the graph. And that's because typically when we're talking about application problems, especially when one of the coordinates deals with time, so time always starts at 0 units. So that's why often the y-intercept is our initial point that we graph for these problems. We could go ahead and graph the others using the slope, which was either up 3,000 over 2, or we can go up 1,500, so that's up 1.5 units and over 1. Or we could just look at these table of values that we came up with and graph those 3 points. But the big thing here is the y-intercept is often the starting point of a line, especially when we're dealing with application problems. All right, moving on to this discovery problem. It says find the x and y-intercept of the following linear equation. So go ahead and pause the video and do that on your own. That's review from last week. So that's what you should have gotten for the x and the y-intercept. And now pause and go ahead and find the slope between those two coordinates. So the slope should simplify in this problem to +2. Remember, it doesn't necessarily matter the order that you subtract as long as you're consistent. But what I want you to see is, okay, so this is our slope of +2, and specifically look at our y-intercept, 0, 3, and now look at our equation. So you should recognize this is a form of a line called slope-intercept form. And the exact reason it's slope-intercept form is because the value, the coefficient in front of x, is the slope. That's the rate of change in the problem. And the starting point, or the y-intercept, is the value tacked on at the end. So let's get the official note for that. So slope-intercept equation is sometimes called the shortcut graphing equation because when it's in this form, you don't have to go through the process of making a t-chart. So we just talked about m is the slope and b represents the y-intercept. So example 1 simply wants us to find the slope and the y-intercept of each line whose equation is given. So it's pretty simple when y is already isolated. So notice in general form, y has to be by itself, and we have y by itself in this first problem. So our rate of change, or our slope, is the m value, or the coefficient in front of x. So that's 4 over 5. And remember what 4 over 5 means. That means rise 4, run 5. And our y-intercept, get a habit of writing y-intercept instead of writing b. Sometimes I think we forget exactly what b represents. And that's all they want in these first two problems. Find the slope, find the y-intercept. Only difference on part B is y is not isolated yet. So we need to do just a little bit of algebra to put it in slope-intercept form first. So to isolate x, you think back to chapter 2 when we solved for a variable, we're going to subtract 2x from both sides since 2x is positive on the left-hand side. 5 minus 2x, remember those are not like terms. Remember our goal is to put it in y equals mx plus b form. So that means we want to write the negative 2x first and then the positive 5 to get it in slope-intercept form. If we do that every single time and we're consistent, it makes it very easy to find the slope, which is negative 2. If you want to write it as a fraction, you can say it's negative 2 over 1. And the y-intercept is 0, 5. So now that we know how to find those two key values, let's use them to graph letter C here. So we could, of course, graph this using intercepts or a t-chart, but we're going to focus on graphing it in slope-intercept form. So we need to isolate y first. All right, and in much the same way, we're going to subtract 3x from both sides first. So we've done that, and we get negative 4y equals negative 3x plus 7. And then we're going to divide everything by negative 4. Negative divided by negative, of course, is a positive 3/4. Positive divided by negative is a negative. It might also be helpful to make the y-intercept a decimal. The slope we never want to write as a decimal. Remember, slope is rise over run. But negative 7/4 is the y-intercept, so it might make it a little bit easier to write it as a decimal. So when we graph it on the chart, it's a little simpler. And now write our slope. So our slope in this problem is positive 3 over 4. And our y-intercept is 0, negative 1.75. And remember, it's also the start point. So we're going to graph the start point first. So 0, negative 1.75 would be somewhere roughly in between negative 1 and negative 2 on the y-axis. So this sometimes can be tricky when we're trying to go up 3 over 4 from a decimal. Remember, that's what we're doing because the slope is 3 over 4. So rise over run means we are rising 3 and running 4 from the start point. So I'm going to go up 3. So up 1 would be right here, just above negative 1. Up 2, up 3. And notice how we're staying in that same position just above one of the horizontal lines. And then we go right 4. And there's our second point. And of course, we could keep doing that and graph as many points as the problem called for. Or since a line goes both ways, we can do the opposite. Remember, the slope originally was a negative over a negative. So we could also go down 3 and left 4 and get points that way. Either way, you need 2 or 3 points to graph a nice diagonal line. And that's the process we're going to go through. Pause the video and try that last one on your own. And I'll show the answer here in just a couple of seconds. So there's the algebra behind this problem. The y-intercept ends up being 0, 1. The slope is negative 2/3. And remember, technically you can write that slope either one of these ways. Doesn't matter where you put the negative number. And that's what the line would look like after you graph the y-intercept here at 0, 1 first. And then either go down to right 3 or up to left 3 to get that line.